In physics, energy is never lost. It just changes its account. When a skateboarder drops into a bowl or a roller coaster plunges down a hill, a massive exchange is happening. Today, we're looking at the perfect trade-off, the transfer between kinetic and gravitational potential energy. By the end of this video, you will be able to 1. Explain how energy moves between stores. 2. Apply the law of conservation. 3. Master the math used to predict height and speed. And 4. Analyze energy flow in real-world systems. The law of conservation of energy tells us that in a closed system, energy cannot be created or destroyed. For a falling object with no air resistance, every joule of gravitational potential energy lost must become a joule of kinetic energy. Here is an exam secret. Because mass is on both sides of our equation, it actually cancels out. This means that, ignoring air resistance, a feather and a brick will reach the same speed falling from the same height. Let's calculate speed from height. A 5 kilogram block slides down a 2 meter ramp. First, find the GPE, that's mass times gravity times height, giving us 98 joules. Since energy is conserved, that 98 joules becomes kinetic energy. Rearrange the formula to solve for V, and we find the block is moving at 6.26 meters per second at the bottom. A pendulum is energy conservation in constant motion. At the highest points of the swing, the energy is all GPE. As it passes through the center at its fastest speed, that energy has been completely swapped for kinetic store. Roller coasters work the same way. The motor does work to give the car GPE at the top of the first hill. From there, the ride is just a series of swaps between height and speed. Engineers use these exact formulas to ensure the car has enough KE to make it through the loops. Key takeaways. Energy flows between KE and GPE stores, while the total remains the same. When an object falls, it loses height but gains speed. You can equate the formulas to solve for unknowns like height or velocity. In the real world, some energy is always lost as heat due to friction. Join us next time as we explore specific heat capacity. Hello learners! Feel free to drop by and visit our website for more free resources, worksheets, and tuitions. Visit us at www.anselhillacademy.co.uk today to get started, and subscribe for more updates, tips, and learning materials.